Hello, hello. Okay, so we are just going to go ahead and factor polynomials completely. I'm not quite sure if there needs to be a definition for greatest common factor, difference of two squares, and then sum or difference of two cubes. There are specific formulas. In fact, I actually am going to pause my recording and come right back. Okay, so this is some of the stuff that's at the top of the page. This is a 4.4 factoring polynomials from the Big Ideas book. It is a homework assignment. So the sum of two cubes, there's generally speaking, I don't like to memorize formulas, so I don't know these formulas by heart. I like to think about the big picture and understand why things are happening the way that they are. So that's how I usually unfactor or usually factor out certain things. There are in certain cases with regard to having a need to be fast at the content and completing the content quickly. So, memorizing a formula might be helpful. I don't do it. You can, whatever floats your boat. Okay. So we're going to start with the first one. And if you need to pause this video to take these notes, absolutely pause it, take these notes, and then go ahead and come back. Okay. So our first problem is 4, and I'm always going to write X because I hate all the other variables. It's just who I am. So the first thing that we're always going to do is we're going to factor out the greatest common factor. In this particular case, between 4 and 100, 4 is my greatest common factor. And with x to the 5th and x to the 3rd, x to the 3rd is my greatest common factor. Actually, the variable with the lowest exponent is always going to be the greatest common factor. So then when I factor out the GCF, I go ahead and I say, okay, what would happen when I take this particular number, 4 and x to the 5th, and I divide it by 4 and x to the 3rd. I know the 4s will cancel, and then I know I'm going to subtract my exponents, so I'm only going to be left with x squared. So that's going to go in here. And then what happens when I take my second number, my negative 100x to the 3rd, and I divide that by x to the 3rd. So I know my x's will cancel, and I'm going to divide my negative 100 by 4, and I'm going to actually end up with negative 25. So I have just now factored the greatest common factor out of this polynomial. However, I do want to mention that this is a difference of two squares binomial, so we can factor it still. Oh, whoops, that's supposed to be a 3. Ha ha. Okay, so that's going to be x minus 5 and x plus 5, because I'm going to take the factors of the first, get those two, x times x, the factors of the second, get those two, 5 times 5. And then I've done this problem so many times, I know that one is going to be plus, one is going to be minus. If you're like, how did you know that? I go in here and I take a look at this formula right here. One is positive, one is negative. It doesn't quite matter which one goes first, which one goes second, so long as they're both there. Okay. All right. So then I have the second one is 2m to the 6th minus 24m to the 5th plus 64m to the 4th. Again, my first job is to take out my greatest common factor. So my greatest common factor in this case with regard to the numbers is 2. And then with regard to the variables, I'm going to take a look and say, okay, I have 6, I have a 5, and I have a 4. And actually, it's going to be 4 because that's the lowest exponent. So that just means I'm going to have at least 4 m's in each of my terms in my trinomial. Okay, so I don't need to always do this kind of math right here. I can simply do that math in my head, okay? So what is 2 divided by 2? That's 1, and m to the 6th divided by m to the 4th is m to the 2nd. Okay, so negative 24 divided by 2 is negative 12, and then m to the 5th divided by m to the 4th is just plain old m. Then we're going to have 64 divided by 2. That should be 32. And then my m's are going to be left as is. And then going ahead and looking at this, I think I can actually factor that. So if I take a look at my factors of 32, I have 1 times 32. Since I wanted to add up to negative 12, I'm going to undo this. And I'm going to say it's negative 1 and negative 32. Negative 2 and negative 16. What else do I have? Negative 4 and negative 8. I can't do 6. Oh, dang, look at it. Look at that. Here we go. So I have m times m, and then negative 4 times negative 8 is going to be positive 32. But then when I add negative 4 and negative 8, I'm going to have negative 12. Don't forget to leave this first one up front. And then that's my final answer. Okay. All right, let's take a look at number 3. So this one is the difference of 2 cubes. So I know, I know that this is c cubed minus 3 cubed. So realistically, I know I'm going to have c minus, hold on one second, c minus 3. And then, c minus 3. And then after I factor that out of here, I'm going to have c squared minus 2 times 3 times c plus 3 squared. So if we take a look at this, oh, sorry, it's without the 2. So the difference of 2 squares, of 2 cubes. This is the formula that I'm looking at right here. So a minus b, and then a squared, and then I have a b squared, and then I have an a times b. So no 2, and that's positive. Okay, so realistically, I'm looking at, see, that's what happens when I try to memorize formulas. I get them mixed up in my head. It is not worth it at all, but whatever. I do know a lot of students do like memorizing formulas. It's a little bit easier, so that's where it goes. Okay, so let's take a look at number 4. So number 4 is the same idea. I have y to the 3rd plus, if I'm not mistaken, and I'm going to just pull up my calculator really quickly. I don't know if you can see that or not. But I am going to take the cube root of 512 and get 8 to the 3rd. So all I did was I just pushed 512 and then the cube root of that. So then I'm going to have y plus 8, y squared minus 8y plus 64. And I got the 64 from the 8 squared. Okay. All right, let's take a look at problem 5. 2k to the 3rd minus 20k squared. And I want to say that this is going to be factor by grouping. And so when you factor by grouping, you take the first 2 terms and you factor out the greatest common factor from those 2, and then you take the last 2 terms and you factor out the greatest common factor from there as well. So in this case, I'm going to have 2k squared. That's my greatest common factor. And I'm going to be left with k minus 10. And then in the case of the blue parentheses, I am going to have negative 5 and be left with k, k plus 10. Did I rewrite something incorrectly? I for sure rewrote something incorrectly. That's supposed to be a positive, which means my signs will be different. Okay, so what does that mean for us here? If this is a positive 5, so this is going to be positive 5, and then we'll be left with k minus 10. So I want you to pay attention to the following. Do you see how this and this is the same exact set of parentheses? So we're going to take that and we're going to say k minus 10 is going to be one set of parentheses that we're going to multiply by. And then this plus this is going to be another set of parentheses that we're going to multiply by in order to get our original piece. So if you don't believe me, I do want you to take a look. So this is your final answer. I do want you to go ahead and actually do multiple distribution and see how this comes back to this particular problem, okay? And you can do that with any of them. Like you can take this whole piece right here, do multiple distribution, you're going to end up with this. Take this piece right here, do multiple distribution, you're going to end up there. It's going to work with all the problems, okay? All right, so then I have problem 6 is 9n to the 6th. I don't know why I'm doing n, but okay. Whew. N to the 3rd. So 6561 divided by 9 is 729. So the 9 is going to be my greatest common factor as a whole number, and then n to the 3rd. So this will be left as n to the 3rd minus 729. And if I'm not mistaken, 729 is 9 cubed. So I'm going to take this and take it a step further. So usually in like algebra 1, a lot of times what's going to happen is, a lot of times you're just going to have, you know, you factored once and then you're done. In this case, in algebra 2, you're going to factor, and then sometimes you're going to factor again, and then sometimes you're going to factor even more. Okay. In this case, this is what it's like. You're going to do factor n minus 9, and then you're going to have n squared plus 9n plus 81. I don't think that we can factor this even more because my factors of positive 81 are 1 and 81, 9 and 9, 3 and 27. And none of these add up or subtract to positive 9. They could give me a 0 if I had these two. They could give me a 24, but not a 9. So then this would be my final answer. Okay. If something doesn't make sense, definitely go ahead and like pause the video and start the video again. Hopefully this makes sense. And if it doesn't, reach out to me. Okay. Bye.